In this next unit, we're looking at sequences and series, and these are ultimately lists of numbers that we do kind of some fancy stuff with. So let's jump right in. All right, so sequences is what we're talking about first. A sequence is an ordered list of numbers. So it is important that it's an ordered list as opposed to a collection. So for example, 1, 1, 2, 3 is not the same as 3, 2, 1, 1. Those are two different sequences because the first sequence goes from 1 to 1 to 2 to 3. The second goes from 3 to 2 to 1 to 1. They're the same collection of numbers though, so if it was just looking at a collection, we would consider these, indistinguishable. But sequence does have an order to it. And then a series is the sum of a given sequence. And I want to be really clear here, it isn't the value of the sum. It is actually the sum itself. So like writing out the numbers together. So for example, 1 plus 2 plus 3 plus 4 is the series. Now 1 plus 2 plus 3 plus 4 is equal to, 10? So the series is equal to 10, but the series is actually this part here, the 1 plus 2 plus 3 plus 4. This is the series, and this is, you could, say the solution to the series, or the answer to the series, or something like that. So I do want to point that out. A series is specifically a sum of numbers. And then like before, order does technically matter, though for series we don't, at least in this class, we don't care too much about the order, because we do care a lot about the solution often, but I do want to make it clear that the series is that number plus number plus number plus number, not what all of that is equal to. And I've written over my next line, so let me erase that. And then an infinite sequence or series has, as you might have guessed, infinite terms. So if I add 1 plus 1 plus 1 plus 1 plus 1 an infinite number of times, that would be an infinite series. If I just wrote a list of an infinite number of numbers, that would be an infinite sequence. Now for this class, we're only going to really be talking about series, but I will mention this here. A sequence is considered to converge if the limit as n approaches infinity of a sub n is equal to a number. So in other words, if as you go out to infinity, there's some patterns such that you would expect the infinite number to be a specific value, then that sequence converges. Otherwise, it diverges. So if you had something like 1, 1/2, 1/4, 1/8, etc., and every time you divide by 2, you can see that this is going to approach 0. So we would say that that sequence converges. It converges to 0. Likewise, if it was, I don't know, all of this plus 1, so 2, 1.5, 1 1/4, 1 1/8, it would all be approaching to the final value of 1. A series converges if the sum is defined. So in other words, if that sum of adding all those numbers together is equal to some number. So if it's equal to 5, if it's equal to an irrational number, if it's equal to something, meaning not equal to infinity. So if it's anything but infinity, it's going to converge. There are some odd ones, like 1 plus -1 repeated, so 1 plus -1 plus 1 plus -1, right? So every other term it hops between 1 and -1. This does not converge because at infinity you don't know if you ended at 1 or at 0. So that's the one example where it gets kind of weird, or if it's just literally random numbers added together, positive and negative, you don't know what that's going to converge to. All right, so the types of sequences in AP Calculus BC, I'm just going to talk through these real quick. We'll do them in detail as we go throughout this unit. Whoops, got ahead of ourselves. So geometric. This is when each term is the previous term times a constant. Harmonic and P-series, this is basically 1 over some number raised to some power. And that number increases as the series increases. Again, don't worry about these in detail. I just want to kind of give you the idea, and then we'll talk about them and you can take notes on them later. Alternating series is any series where it goes positive, negative, positive, negative, positive, negative, positive, negative. A power series is basically a series where you've got terms and then they're multiplied by x, and then the next term is multiplied by x squared, x cubed, x to the 4th, etc. And then the Taylor series is just a fancy power series that we'll talk about later. But as you can see, there's basically 5 series that you need to be familiar with. And so the next couple lessons, we'll get into talking about those.